Let us start with Module 1 of our subject, Basics of Electrical and Electronics Engineering. So first of all, let us see some basic terminologies related to electrical engineering. So all these terms you have studied in your higher secondary classes. Now let us just recollect those terms. So first of all, let us see what electrical engineering is. Electrical engineering is an engineering discipline concerned with the study, design and application of equipments, devices and systems which use electricity, electronics and electromagnetism. So electrical engineering is simply a branch of engineering in which one has to study and design various equipments and devices that uses electricity, electronics and electromagnetism. So now a circuit. A circuit is a combination of various elements to form a closed path for the flow of electric current. So a circuit is formed by interconnecting various elements and it should be a closed path for electric current to flow. So a circuit is a closed path formed by a number of components for the flow of current. So now electric current. So all of you know what electric current is. Electric current is simply defined as the flow of electrons. So you may have studied this definition. Electric current is the flow of electrons. So this is the simple definition for electric current. So we have to study the actual definition. So now electric current is of two types. We can divide electric current into two types. First one is direct current, abbreviated as DC, and the next one is alternating current, abbreviated as AC. So what is the difference between direct current and alternating current? So direct current is that current whose magnitude and direction does not changes with respect to time. So for direct current, the magnitude and direction does not changes. That is, it always remains constant. Irrespective of the time, the magnitude and direction of the current always remains constant. So this is the graphical representation of direct current. So see, even if the time varies, the magnitude of direct current or DC voltage always remains constant. The magnitude remains constant as well as the direction. Direction means the polarity does not changes. It will either be positive always or it will be negative. So the magnitude and direction does not changes with respect to time. That is a direct quantity. Can be a direct current or a DC voltage, direct current voltage. So the next one is the alternating current. And an alternating current is a current whose magnitude and direction changes with respect to time. So this is the graphical representation. So we can see from here, as the time changes, the magnitude changes as well as the direction also changes. So for an alternating current, the magnitude as well as the direction changes with respect to time. So see this in this particular instant of time. So at this instant, the magnitude of this current is this much. So if we consider this particular time, here the magnitude is this much. So that is why we are saying that the magnitude changes with respect to time. And now see the direction. From this point up to this point, this quantity is positive. And from this point to this point, it becomes negative. That is what meant by the change in direction. So for an alternating quantity, the magnitude changes with respect to time and also the direction changes with respect to time. So that is what direct current and alternating current are. So നമ്മൾ already പഠിച്ചതാണ് DC ഉണ്ട് AC ഉണ്ട്, direct current and alternating current. Direct current ആണെങ്കിൽ it remains always constant. അതിൻ്റെ മാഗ്നിറ്റ്യൂഡും ഡയറക്ഷനും എപ്പോഴും കോൺസ്റ്റൻ്റ് ആയിട്ടിരിക്കും. ബട്ട് ഇൻ കേസ് ഓഫ് ഓൾട്ടർനേറ്റിംഗ് കറണ്ട്, both these parameters, both magnitude and direction changes when time changes. So next is a DC circuit. So we have already seen what a circuit is. Okay, a circuit is a closed path for the flow of electric current. And now a DC circuit is a closed path for the flow of DC, direct current. And a simple DC circuit is shown in this figure. And the essential components of a simple DC circuit are: there should be a source, there should be connecting wires, and a load. Now, source is nothing but that part of the circuit that supplies the power. There should be something to supply the power, and that part is known as the source. And here in the circuit, this battery or this cell acts as the source of power. And there should be wires to connect the various components. And the next part is the load. Load is that part of the circuit that receives the power supplied by the source. So here this resistor acts as the load in this particular circuit. So next term is active and passive components. So we have already said that in an electric circuit there will be a number of components. And a circuit is formed by interconnecting a number of components, and that various circuit components can be categorized as follows. That is, they can be categorized as active components and passive components. So now, what are active components? Active components are, as the name indicates, the components which are capable of supplying power. So these active components can supply power to an electric circuit. For example, battery and generator. So we know battery, if we connect a battery to a circuit, it can supply power. A generator also is capable of supplying power. So they comes under the category active components. Now, the next category of components is the passive components, and they are the opposite of active components. They are not capable of supplying power. They cannot supply a power to a circuit. They can just modulate the power supplied by this active components. Modulate means they can control that power. They can either vary or control the power supplied by the active components. Example of passive components are resistors, inductors and capacitors. So active components എന്ന് പറഞ്ഞാൽ ഒരു സർക്യൂട്ടിലേക്ക് പവർ സപ്ലൈ ചെയ്യാൻ പറ്റുന്ന കമ്പോണൻസ്. പാസീവ് കമ്പോണൻസ് എന്ന് പറഞ്ഞാൽ പവർ സപ്ലൈ ചെയ്യാൻ പറ്റില്ല. ഈ ആക്റ്റീവ് കമ്പോണൻസ് സപ്ലൈ ചെയ്യുന്ന പവറിനെ മോഡുലേറ്റ് ഓർ കൺട്രോൾ ചെയ്യാൻ പറ്റും ഈ പാസീവ് കമ്പോണൻസിന്. എക്സാമ്പിൾ റെസിസ്റ്റർ, ഇൻഡക്ടർ ആൻഡ് കപ്പാസിറ്റർ. So now the next term is electric current. So simply we will define electric current as the flow of electrons. But the exact definition for electric current is that electric current is the time rate of flow of charges passing through a conductor. So it is the rate of flow of charges through a conductor. The rate of flow of charges. So how will we calculate the rate of change of something or rate of flow of something? So rate of change of a quantity is taken as the first derivative of that quantity with respect to time. So rate of flow of charge, we can write it as d by dt of q. Charge is denoted as capital letter Q. So current is actually the rate of flow of charge through a conductor. So rate of flow, rate of something we actually calculated as the quantity divided by time. എന്തിൻ്റെയും rate of change, നമ്മൾ time rate of change calculate ചെയ്യുന്ന that quantity divided by time. So rate of flow of charge means charge flowing per unit time. Charge divided by time. അതായത് ഒരു യൂണിറ്റ് ടൈം എടുത്താൽ ഒരു സെക്കൻഡിൽ എത്ര എമൗണ്ട് ഓഫ് ചാർജ് ഫ്ലോ ചെയ്യുന്നു, That is what is meant by electric current. It is the rate of flow of charge. Charge flowing in a unit time interval. അതായത് ഒരു സെക്കൻഡ് നമ്മൾ കൺസിഡർ ചെയ്താൽ ആ ഒരു സെക്കൻഡ് ടൈമിൽ എത്ര കൂളംബ് ചാർജ് ആ കണ്ടക്ടറിൽ കൂടി ഫ്ലോ ചെയ്യുന്നുണ്ട്. ദാറ്റ് ഈസ് ടേംഡ് ആസ് ദ ഇലക്ട്രിക്കൽ കറണ്ട്. So it can be represented as dq by dt. If a charge of dq is flowing through a conductor at a small interval of time dt, current will be equal to dq by dt. Or it can be written as I is equal to q divided by t. Electrical current is denoted by capital letter I. I is equal to q divided by t, where q is the charge and it is expressed in coulombs. Unit of charge is coulombs, and t be the time interval considered in seconds. So we can write the unit as coulomb divided by second. So coulomb per second, or the SI unit of current is amperes, or we will use capital letter A. So unit of current is amperes. So next term is the electric potential. So potential at a particular point is defined as the work done in moving a unit positive charge from infinity to that particular point. Suppose we have this particular point and we need to calculate the potential at this point. So potential at this point is the work done in moving a unit positive charge from infinity to this particular point. Suppose we have a unit positive charge here at infinity, and if we have to move this charge from infinity to this point, we have to definitely do some work. So that work is termed as the potential at this point. ഇൻഫിനിറ്റിയിൽ നിന്ന് ഒരു യൂണിറ്റ് പോസിറ്റീവ് ചാർജിനെ ഈ പോയിന്റിലേക്ക് കൊണ്ടുവരാൻ വേണ്ട വർക്കാണ് ഈ പെർട്ടിക്കുലർ പോയിന്റിൻ്റെ പൊട്ടൻഷ്യൽ. Okay, so the work done in bringing a unit positive charge, that means 1 coulomb of charge. The work done in bringing 1 coulomb of charge from infinity to this point is the potential of this point. So it can be called as voltage also. The potential of this point is called as voltage of this point also. Okay. So we have defined potential as the work done in moving a unit positive charge. That is work done per charge. Work divided by charge. So the equation is W by Q, and unit of work is joules, unit of charge is coulomb. So the unit of potential can be joules per coulomb. And the SI unit of potential is volt, and it is denoted by capital letter V. So that is electric potential. Now let us see what potential difference is. So we have studied what potential at a particular point. Now potential difference is acting between 2 points. Okay. So potential, so we have these 2 points here, and the potential difference between these 2 points is the work done in bringing a unit positive charge from one point to the other point. So we already know both these points have a potential. If a charge is there at infinity, we have to do a work to bring this charge from infinity to this point, and that work is the potential of this point. And also, if this charge have to be moved from infinity to this point, we have to do a work, and that work is the potential of this point. So both these points will have a potential, and the difference between these 2 potentials are termed as potential difference between these 2 points. So that is one definition, or otherwise it is the work done to bring a charge from this point to this point. That is the potential difference. So potential difference also have the unit volts. The next one is electromotive force. abbreviated as EMF. EMF is the force which causes current to flow in an electric circuit. So it is the force that causes current to flow in an electric circuit. So we have already seen the diagram of a basic circuit. This is a simple circuit, and for current to flow in the circuit, there should be a source. So a particular property of this source by which current is flowing through the circuit is known as the electromotive force of this battery. Electromotive force എന്ന് പറഞ്ഞാൽ ഒരു സർക്യൂട്ടിൽ കൂടി കറണ്ടിനെ ഫ്ലോ ചെയ്യിപ്പിക്കുന്നത് ആരാണോ ആ പാരാമീറ്ററിനെ പറയുന്നതാണ് electromotive force. So actually current is flowing due to a source, and hence this source will have an electromotive force, and actually the electromotive force is the potential difference between the terminals of the source. Here we have this battery as a source. This battery will have a positive terminal and a negative terminal, and the potential difference between these two terminals can be used as the can be termed as the EMF when no current is flowing through the circuit, or when no current is flowing through this source. അതായത് നമ്മൾ ഈ പെർട്ടിക്കുലർ സോഴ്സിനെ ഒരു സർക്യൂട്ടിലേക്കും കണക്ട് ചെയ്തിട്ടില്ല എന്നുണ്ടെങ്കിൽ ഒരു കറണ്ട് ഫ്ലോ ചെയ്യില്ല. സോ ആ ടൈമിലുള്ള അതിൻ്റെ ടെർമിനൽസ് തമ്മിലുള്ള പൊട്ടൻഷ്യൽ ഡിഫറൻസ് ആണ് അതിൻ്റെ EMF or electromotive force. So EMF of a battery or generator is the potential difference between its terminals when no current is flowing through it. That is electromotive force. So electromotive force is equivalent to a voltage. So its unit is also volt. So now the next parameter is the resistance. Resistance, as the name indicates, is the ability of a conductor to resist, or the ability of a conductor to oppose. To oppose what? To oppose the current flowing through it. So resistance is a property of a conductor by which it opposes the flow of current through it. കറണ്ടിനെ ഒപ്പോസ് ചെയ്യാൻ റെസിസ്റ്റ് ചെയ്യുന്ന പ്രോപ്പർട്ടിയാണ് റെസിസ്റ്റൻസ്. And there are different factors on which the resistance of a conductor depends. And mainly there are 4 factors. First one is length of the conductor. Next, area of cross section of the conductor, material used for the conductor, and temperature. So length of the conductor and resistance of the conductor are directly proportional. As the length of the conductor increases, its resistance also increases. So resistance and length of conductor are directly proportional. Next one is area of cross section. Area of cross section of a conductor and resistance are inversely proportional. With increase in area of cross section, the resistance decreases. So next one is the material of the conductor. So resistance is always dependent on the type of material used for the conductor, whether that conductor is made up of copper, aluminum, silver, etc. Say for example, if we consider a silver conductor and a copper conductor, the silver will be a very good conductor. So silver is a very good conductor means silver will be having less resistance compared to copper. So resistance is dependent on the material also. And next factor is the temperature. So we know the classification of conducting materials: conductors, semiconductors, and insulators. In case of conductors, temperature and resistance are directly proportional. With increase in temperature, resistance also increases. But in case of semiconductors, the temperature and resistance are inversely proportional, because with the increase in temperature, resistance decreases. So we know that in case of semiconductors, if temperature increases, more and more electron-hole pairs are generated. You have studied this in physics. So with increase in temperature, more and more electron hole pairs are generated. Free electrons will be there. So conduction increases. Conduction increases means resistance decreases. So for semiconductors, with increase in temperature, conduction increases and resistance decreases. So these are the various factors on which the resistance of a conductor depends on. And so based on these factors, we can mathematically represent resistance as resistance is proportional to length of a conductor. So R is proportional to L. Resistance is inversely proportional to area of cross section. That is, R is proportional to 1 divided by A. So combining those, we can write as R proportional to L divided by A. And this proportionality can be replaced by a constant rho. So equation becomes R is equal to rho into L divided by A. So this is the equation for resistance. And this proportionality constant rho is known as resistivity or specific resistance of the conductor. So rho is known as resistivity or specific resistance. And the unit of resistance is ohm. This is a symbol of ohm. And so from this equation, we have R is equal to rho L by A. And here we can write as rho is equal to R into A divided by L. So rho is R into A divided by L. So in this equation, let us substitute area of cross section as 1 meter square and length as 1 meter. So A and L are 1. So we will get rho is equal to R. Rho is equal to R. So hence we can define rho, the conductivity, rho is the resistivity. The resistivity rho as the resistance of a conductor having unit length and unit area of cross section. The resistivity will be equal to resistance when that conductor is having 1 meter length and 1 meter square area. So the resistivity of a conductor is the resistance of that conductor if we consider a portion of that particular conductor having 1 meter length and 1 meter square area. A particular conductor resistivity എന്ന് പറഞ്ഞാൽ ആ കണ്ടക്ടറിൻ്റെ തന്നെ 1 മീറ്റർ ലെങ്തും 1 മീറ്റർ സ്ക്വയർ ഏരിയയുമുള്ളൊരു പോർഷൻ നമ്മൾ എടുത്താൽ ആ പോർഷൻ്റെ റെസിസ്റ്റൻസ് എത്രയാണോ അതാണ് ആ കണ്ടക്ടറിൻ്റെ റെസിസ്റ്റിവിറ്റി, ഓൾസോ നോൺ ആസ് സ്പെസിഫിക് റെസിസ്റ്റൻസ്. ആൻഡ് യൂണിറ്റ് ഇസ് ഓം മീറ്റർ. So we know the unit of resistance is ohm, that of area is meter square, that of length is meter. So meter and meter gets cancelled. What we will get is ohm meter. So unit of resistivity is ohm meter. So next parameter is the conductance. Conductance is actually the opposite of resistance. So conductance of a material is the property by which it allows the passage of current through it. Resistance is the property to oppose current, but conductance is the property to allow the passage of current. So it is the reciprocal of resistance. As both of them are having opposite meanings, the conductance is taken as the reciprocal of resistance. So conductance is denoted by the letter G, capital letter G, and it is equal to the reciprocal of resistance. G is equal to 1 divided by R. So we know that R resistance is rho L by A. So 1 by R becomes A by rho L. And here this term 1 divided by rho can be replaced by a constant sigma. So sigma into A by L. 1 by rho is replaced by sigma. Sigma into A divided by L. And sigma is known as conductivity or specific conductance of the material. Now the unit of conductance G. Unit of conductance is ohm inverse. Why? Conductance is 1 divided by R, that is 1 divided by ohm, that is ohm raised to minus 1, or mho. So ohm is reversed line, OHM, mho. And the symbol is inverted ohm. This is a symbol of mho. So as conductance is the reciprocal of resistance, its unit is ohm inverse or mho. So sigma is the conductivity or specific conductance. So see, from this equation we can write sigma as, so here we have G is equal to sigma into A by L. So here we can write sigma as, see, sigma is equal to G into L divided by A. G into L divided by A. So if we substitute A as 1 meter square and L as 1 meter, both of this will get cancelled. Both are 1. So we will get G is equal to sigma. So G is equal to sigma, or we can define sigma or conductivity as the conductance of a material having unit length and unit area of cross section. So conductivity of a material is its conductance when we consider a part of that conductor having 1 meter length and 1 meter square area. ഒരു കണ്ടക്ടറിൻ്റെ കണ്ടക്ടിവിറ്റി എന്ന് പറഞ്ഞാൽ ആ കണ്ടക്ടറിൻ്റെ തന്നെ ഒരു 1 മീറ്റർ ലെങ്തും 1 മീറ്റർ സ്ക്വയർ ഏരിയയുമുള്ളൊരു പോർഷൻ നമ്മൾ കൺസിഡർ ചെയ്താൽ ആ പോർഷൻ്റെ കണ്ടക്റ്റൻസ് ആയിരിക്കും ആ പർട്ടിക്കുലർ കണ്ടക്ടറിൻ്റെ കണ്ടക്ടിവിറ്റി. Okay. So now let us see what is the unit of conductivity. So this is the equation for conductivity, G into L divided by A, and unit of G we have already written as mho. So mho into length is meter, area is meter square. So meter and meter gets cancelled and unit becomes ohm per meter. So unit of conductivity is ohm per meter. Resistance and conductance are very, very important terms.